Hello class, this is going to be your notes for January 23rd, 2017. Hopefully you've already done your warm-up. The video is paused for about 5 minutes at the beginning of class. And you've gotten this warm-up done, but if not, follow along, make sure you know what you're doing, and if you did do it, make sure you did everything right, alright? So we're going to go ahead and jump in here to the warm-up. Number 1, we have to find x, we need to round to the nearest tenth. So first off, before we even do anything calculation-wise, we need to know what we're going to use and what we were given. So we're using this angle, 59 degrees, right? Our x here is the side opposite of our angle, so that is our opposite side. And we're given our two legs, so we know that. So we're gonna have our opposite and our adjacent. We just need to figure out which one's which. So the 18.5 is going to be our adjacent, and it is the one that makes the angle with the hypotenuse, so that is correct. It is our adjacent. And we have our angle of 59 degrees, so we have our opposite and our adjacent, so we need to figure out, are we using sine, cosine, or tangent? And tangent has the O and the A, so tangent is the winner here. So we're going to use tangent of 59 degrees equal to our opposite, which is x, we don't know yet, over 18.5. Now the first step here is to get rid of, or get x all by itself. So we need to get rid of that 18.5 on the right, move it over to the left. So to do that, we're going to multiply both sides by 18.5, and that will eliminate the 18.5 on the right side. So we're left with, I'm going to rearrange it to where x is equal to 18.5 times tangent. You can just, you don't have to write times in between, you just put them together, and 59 degrees. So now we can just plug this into Desmos, and it'll give us our answer. So let's jump over to Desmos. Now, when we have our Desmos open, we just type in everything we need. So 18.5, and then inside of this functions button off to the right is where all of our trig functions are. We also have some stat stuff we won't really talk about in this class, and some miscellaneous things like finding the greatest common denominator, the least common multiple. It can auto round for us if we wanted it to. We can add in a different exponent. We can even do some calculus with some and some summations, but we're not doing any of that. We're using trig. So our trig that we're going to use specifically is tangent, which we already said, and tangent of 59 degrees. Now if you notice, we just got a negative number. That is not good. So anytime you are using any of these things and you're using the trig functions, you want to make sure that whatever calculator you're using is in the right mode. So if you notice, we have this little wrench on the top right, and if you notice there, the bottom of the options here for your settings, the bottom it says radians and degrees. We're in radian mode. We don't use radians yet. We will use them next unit, but we aren't yet. You don't know what radians are. So we are not using radians. These are different units for the measurement of an angle. Radians is great for using with circles more than triangles, but it can help with triangles as well. So we're going to use degrees. We're going to click the button for degrees, and you notice our answer automatically changes to a 30.78, said to round to the nearest tenth, so 30.78 round to 30.8. So that's going to be our answer. So let's write that in there. So 30.8. And there, we don't have any units for this, so that's just going to stay as 30.8. We're not trying to find angle, we're not trying to find a specific measured length, so that just stays as it is. Now, for number 2, let's look here again, figure out what we are given and what we're trying to find. So here our x is our angle. We don't know what our angle is, so that means we're going to use our inverse, tangent, cosine, sine, one of those three. So, if we look here, we have our 9, which is a leg, and it is the leg that helps the hypotenuse make the angle. So, that means our 9 is our adjacent, and then the 13 is our hypotenuse. It's the one across from our 90-degree angle, and it is also the largest side of the triangle. With the right triangle, that's always going to be our hypotenuse. Don't have a hypotenuse in other triangles. So we got 9 and 13, those are A and H. So A, H goes with C, so cosine is what we're going to use. So cosine of some mysterious angle we don't know yet, in degrees, is equal to our 9 over 13. So now, what we're going to do, just like plus, or adding and subtracting our opposite operations, for cosine, your opposite operation is inverse cosine. So you just do cosine inverse instead of, so basically we just switch our x in the fraction. So 9 over 13 goes inside, and now the x is on the outside. So now we can just plug that straight into Desmos and we'll come out with our x. So again, let's jump over to Desmos. And again, inside of the functions key, the middle column is our inverses. They're also known as arc. So arc sine, arc cosine, arc tangent. Those are the same as inverse cosine, inverse sine, and inverse tangent. It's the same thing. We're using inverse cosine, and our angle, or our ratio is 9 over 13. And if you wanted to close the parentheses, you just move over once and close it, but you don't have to. Our answer is already there. So the 46.18. Again, we're rounding to the nearest tenth, so 46.18 rounds up to 46.2. So go back to our notes again. And our answer is the 46.2. Now we need to use it on here because we're talking about the angle. It's degrees. And there we go. So there's our warm-up. Alright? Alright, so let's get into our notes for the day. Alright? We got 2 vocab words we're looking at. Angle of elevation and angle of depression. Now, these are basically just going to be using our sine, cosine, tangent in real-world situations where things are up in the air, or that's really about it. Or things are down below where you're standing, things like that. Things are up in the air that you're looking at and you're on the ground, or you're up in the air and you're looking down. It's various forms of those things. So here's our first one. We got a circus act, and here's, like I said, somebody up in the air, and they're looking. There's a person down on the ground watching them while they're up in the air. So they're up on a person in the audience at ground level watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? Nice for us, there's already a picture drawn. We don't have to draw a picture. First thing we should do always is draw a picture. Unless there's one given to us, we can use that to our advantage. So here we are given our picture. Even has our angle in there, has everything we need. The only thing we need to do to that picture is the fact that the person in the audience is looking at the top of their head. So we need to look at that as well. So instead of just having the 25 feet or just the 5.5 feet, we need to have those added together. So you add 25 and you add 5.5, sorry. So 25 plus 5.5, and that gets you 30.5, and that is the length from here down to the audience member. So that's going to be our height there. Now, we need to figure out what are we going to use here. Still using sine, cosine, or tangent, right? So SOHCAHTOA still applies. Always will. And we need to figure out which one we're going to use. So here, there's our angle, the 27. We're going to ignore that middle blue line. We're using this one up here. We're using this side over here, off to the left. And then the ground is our other leg. So there's our right triangle. we're looking at, or the 30.5 is going to be our opposite, right? Because it's on the other side of the angle. So this is our, sorry, that's a bad circle. That's our O. X is going to be our adjacent. So that's what we're looking for. And again, we have opposite. We're looking for adjacent. We have our angle. So TOA uses O and A. That's our tangent. So we're going to use tangent. So tangent of 27 needs to be equal to our opposite, which is the 30.5, over our adjacent, which is our x. Now, this is a scenario we've only come across on worksheets, right? Hopefully you did the work you've gotten so far. If not, it's okay. Just try to keep up and keep on keeping on, right? We'll get you what you need to do. So, we have our tangent of 27 equal to 30.5 over x. Now, there's a process you can do to get x by itself, but it's basically two steps of algebra. You multiply both sides by x, then you divide both sides by tangent of 27. It's two steps. It works, but I kind of like the cheat with this is to take your tangent and your x and you just switch them. That's what you're going to end up doing by doing that two-step process. It just makes it to where it's a one step and you're done. It's easy. So x is equal to the 30.5 over tangent of 27. Not 72, 27. Okay. So now again, we're going to plug this into Desmos. So let's go to Desmos. Okay, so here we are on Desmos. So what we're going to plug in is exactly what we just had written down. 30.5 divided by our function, which is going to be our tangent of our angle of 27. Close the parentheses, and there's our answer, 59.85. I don't believe it said to round to anything specific. Let's check. So 59.85, we round that to be 59.9. It's probably a good answer. Doesn't say anything specific to round to, so let's go with that. 59.9. Now, we do have a unit here because this is talking about an actual distance from the high wire person to the audience member, and it is in feet. So there's our unit, there's our answer, and we're done. Alright, so now let's look at the next problem. Okay, here's our next problem. We have a multiple choice one now, so you don't really need to write it down, just pay attention. So, at a diving competition, a 6-foot tall diver stands atop a 32-foot platform. The front edge of the platform projects 5 feet beyond the ends of the pool. Very important, gotta remember that. The pool itself is 50 feet in length. A camera is set up on the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation to the nearest degree? So, what we're looking for here is the angle now. So we're not looking for the distance the camera is away. We know that. It's 50 feet from the opposite edge of the pool. But it's not 50 feet away from where he is, or where she is. I don't know what sex this diver is, but it's a 6-foot tall diver. So we need to draw a picture. So let's get our picture drawn. Alright. So here's our diver up at the top of the little platform. We know that the platform sticks out over the edge. Let me redraw that line. Make them really towards the end here, right? So this is 5 feet here. This is 6 feet here. Ooh. Right there. This is 5 feet here. And then our pool goes out like this, 50 feet. And our camera is down at the line of sight of the pool, or edge of the pool. So here's our line of sight for the camera. And then here's going to be our triangle. Okay? So that 50 feet, though, is the entire length of the pool. So we need to take out that 5 feet. And our height there is not just the 6 feet, and this is 32, by the way. 32 feet here. We need to add those together to get our overall height. So 32 plus 6 is 38. So that's our one leg. And then the other leg, 50 minus 5, which is 45. So that's our bottom leg here. Okay? And we are looking for this angle here, our x. So, what we need to do, we have our two legs, so that's opposite and adjacent. 38 is our opposite. 45 is our adjacent. So we're going to use those two with tangent, because again we have opposite and adjacent, so toa is our tangent. So tangent of our mystery angle is equal to our opposite, 38, over our adjacent, 45. Now what we need to do is just multiply, or not multiply, sorry, trying to find our angle, so we're going to use inverse tangent. So x, again we're just going to switch where x and our fraction is equal to the tangent of 38, no, not tangent, sorry, let me fix that, tangent inverse of 38 over 45. We plug in tangent there instead of tangent inverse. That would give us a very, very wrong answer. Alright, so there's what we're looking for. Let's go ahead and jump back over to Desmos and get our answer. So here we are at Desmos. We have to just plug in our what we're looking for, right? So inverse tangent, so that's going to be inside of our functions. The middle one for the inverses, the third one down is tangent, so arctan of 38 over 45. And there's our answer automatically. And it wants us to round it to the nearest degree, so that's just going to be 40. That's 40.1. We're round down to 40. So our answer is just going to be 40. So it's 40 degrees. And that's going to be C, right? Okay, sorry about that, guys. I kind of had a bit of a brain fart. I think that I might be doubling up here, but I'm not going to re-record this whole video just for this. But just in case I did record this, I'm going to record it again. So if you're hearing this again, sorry. But X is 40 degrees. This is my first video, so give me some leeway here. So X is 40 degrees. That means that our answer is C. So there we go. See, a circle takes over C. Next problem, looking at angle of depression. The main difference between angle of depression and angle of elevation is that angle of depression is looking down, angle of elevation is looking up. So here we have Maria at the top of a cliff, and she sees a seal in the water. If the cliff is 40 feet above the water, and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff in the nearest, or at the nearest foot? So we need to just round this to the whole number. Now, the main difference between angle of depression, angle of elevation, is the obvious that you're looking up, right? But here, angles don't really work out super easily if you just look at the angle of depression itself. So the picture there kind of shows you what I'm trying to get at here. So when you're using angle of depression, it's that angle that is, if Maria were to look straight out, and that is going to be the AB there, the pink dotted line. She's looking straight out, and then the angle that line makes with the line of sight down to the seal is your angle of depression. So that's the 52 degrees. Now the reason we know that angle C down there is also 52 degrees is because the line DC down at the bottom is parallel to line AB. And because those are parallel, the line AC, the diagonal going across, makes the two 52 degree angles be alternate interior angles. So going back to alternate interiors, we know they're congruent, so that means that if our angle of depression is 52 for the seal. His angle of elevation is 52 degrees as well. So that's nice because now we can use the 52 with our 40-foot cliff and our x to use tangent because we have our two legs of our right triangle to find what x is. So let's do that. So like I said, we're going to use tangent. And tangent of our 52 degrees has to be equal to our 40-foot cliff. That's our opposite over our x, the adjacent. So just like I said before, what we're going to do is just switch the tangent of 52 and the x. That way we already solved for x. We don't have to do any steps algebraically, and we got our solution. So 40 over tangent of 52, and that is our x. Now we're going to jump over to Desmos and get our answer. Alright, so we're on Desmos now. We're looking at 40 over our function tangent of 52. Nope, not 55. 52. There's our answer, 31.25. Wanted us around the nearest whole foot, so that's going to be 31 feet. Okay? So, 31 feet's our answer. Sorry, I forgot I didn't put the equal sign there. 31 feet. And there we go. Okay, so now let's do our next problem. Okay, our next one here, another one for angle of depression. We got that Louisa is in a hot air balloon 30 feet above the ground. She sees a landing spot at an angle of depression of 34 degrees. So we need to find what the horizontal distance between the hot air balloon and the landing spot she sees is to the nearest foot. So let's draw a picture. Like I said, drawing pictures always helps you to visualize what you're looking at, right? So if you don't know what the hell you're doing, first thing you should do is draw a picture. So here's our little hot air balloon with Louisa in it. Okay, so there's the balloon with Louisa, and now we got some landing spots she wants us to find over here. Make it look a little target. So she sees this. Her angle of depression, 34 degrees. And she is 30 feet from the ground. So what we need to do is find our distance horizontally. So that's the bottom leg of our triangle that she is from that target. So that's going to be our x down at the bottom. So we got our 30 foot height, we get our 34 degree angle, and we need to find that x to the nearest foot. So again, because our straight out line of sight and the horizontal distance line that we're trying to find x down there are parallel, we got alternate interior angles, so that 34 is also inside of this triangle here. So really, this is our triangle we're trying to find here. Straight down from her. So we got our opposite. We're looking for our adjacent. So we're going to use tangent again. Tangent's kind of your best friend when it comes to depression and or angles of depression, angles of. Oh, my pen's not working too well for me now. Depression and angles of elevation. So we got tangent there, and we're looking for tangent of 34 degrees. Equal to our opposite of 30 over our adjacent of x, we don't know. That's what we're trying to find. So again, we're going to switch the places. So x is equal to 30 over tangent of 34. So just gotta go plug that into Desmos. Okay, so here we are on Desmos. 30 divided by tangent, so functions tangent 34. Looks like 44.4. So again, that would round down. So 44 feet away from her landing spot. So let's jump back to our work. 44, sorry. Keep saying 34 because of the 34-degree angle. 44 feet. And that's going to be our answer choice C. And there we go. We can see that C is our answer. So, alright. Now, I'm going to make this a bit more difficult. So now we got two angles of depression to see these two dolphins in the water from this boat. And the boat is 154 meters, that's really high, above sea level. So what we need to do is find the distance away for both of the dolphins and then subtract to find the difference between them, because we're trying to find out how close they are to each other. So we got our picture, so that's nice. We're going to say that J and K are the distances as well, so that'll make it a little bit easier. So the grayer dolphin is our dolphin J, and the lighter dolphin is K. So what we're trying to do here is we're basically just going to do our angle of depression twice. And again, we know our angles of depression for each dolphin. We know the vertical height. We want to find the horizontal distance. So that means we just need to use tangent again. Again, the hypotenuses are there, but they don't matter besides making angles. So tangent of 34 degree, not 34, it's 35. I don't know why I'm so obsessed with 34 all of a sudden. 35 is our shorter angle, which means it's our further dolphin. That's J. So he is still 154 meters from the top of the boat, but he is some distance J out. Okay? So that means that J is equal to tangent 154 over tangent of 35. Now for K, use the other angle, that's 36 degrees. Still 154 as our vertical height. So that means that K is equal to 154 over tangent of 36. Now, let's say we're trying to find the distance between, we'll call that X. So let me label that in the picture. X here is this distance. Okay? So that means our X. Sorry, my pen is. I left my good pen at school, so gotta remember to bring that home when I'm doing these. So X is going to be our J minus K. So to find our overall answer in one move in Desmos, we're just going to do 154 over tangent of 35 minus 154 tangent of 36. Make our lives a little easier and just make it one move in Desmos. Okay? So let's go do that. Here we are in Desmos again. So 154 divided by function tangent of 35. Close the parentheses and we'll get away from that fraction, so move the arrow. And then we're going to subtract 154. Again, missed the 5. Sorry. Moved too fast on this app and it doesn't work too well, but it's alright. So, tangent now of 36 degrees. Again, you move too fast and it lags on you. So 7.9 So we got 7.97. So that means we're going to round. I believe it said round to the nearest foot, so that, or meter, I guess. So it's going to be 7.9. We'll round up to 8 meters. Let's make sure that's right. Did it say nearest meter? Yeah. All right. So let's look at our work here again. So our answer is in fact not 7. It is 8 meters. And there's our answer. Alright, so our next slide here is just going to be our exit ticket. I'm not going to work that out for you because I want you guys to figure it out and do it on your own. It is just like this problem. So if you can figure out what you're going to subtract from what, then you're going to be good. And it's again 2 angles of depression. So if you can do this problem, you should be able to do that one pretty easily. Just replace the numbers, really, more than anything. Okay, so here it is. I'll read it for you. Madison looks out her second floor window, which is 15 feet above the ground. She observes 2 parked cars. One car is parked along the curb directly in front of her window, and the other car is parked directly across the street from the first car. The angles of depression of Madison's line of sight to the cars are 17 and 31 degrees. Find the distance between the 2 cars to the nearest foot. Okay, so if you pause here, that'll be the end of the video for me. Go ahead and figure out this exit ticket and have a great day. If you need to rewatch the video, just restart.